This video is about the quadratic formula. The quadratic formula is a fast way to solve any quadratic equation. If an equation is in the form ax squared plus bx plus c is equal to 0, then the solutions to that equations are either x is minus b plus the square root of d divided by 2a, or x is minus b minus the square root of d divided by 2a. And in this case, d is the discriminant and is equal to b squared minus 4 times a times c. So let's see the quadratic formula in use. First of all, let's say we have an equation, and that equation is 4x squared plus 8x minus 4 is equal to 2x squared plus x. Well, first off, we cannot use the quadratic formula right away because we don't have the equations in the form ax squared plus bx plus c is 0. We have something without a 0 on this side. So first we have to make the right hand side 0. So we subtract 2x squared from both sides, and then we subtract x from both sides, and then we do have a form that ends in is equal to 0. So let's see what our a, b, and c are in this case. A is the coefficient before the x squared, so in this case a is 2. B is the coefficient before the x, so in our case b is 7. C is the last one, so in our case c is a negative 4. Do not forget that minus over there. Negative 4. So first we calculate the discriminant. That is b squared, so in our case 7 squared, minus 4 times a, 2, times c, which in our case is negative 4. So that is equal to 49 minus 4 times 2 times 4, so that's 32. But mind that there's a minus over here and over there, so I add them together and I end up with 81. Note that 81 is the square of 9. That doesn't really matter because even if there's not a perfect square here, we can still use the quadratic formula, but it makes it easier. So the next step is writing down the solutions. We have the discriminants, so we can write down the solutions. The solutions are x is minus b plus the square root of d divided by 2a. Now our a, b, and c are the same as before, and the discriminant d is 81. So let's write them down. X is equal to minus b, so minus 7, plus the square root of d, in our case 81, divided by 2 times 2, or x is negative 7 minus the square root of 81, divided by 2 times 2. The first one, x is equal to minus negative 7 plus 9 is 2 divided by 4 is a half, or x is equal to negative 7 minus 9, so it's a negative 16 divided by 4 is equal to a negative 4. Two solutions to this problem. Another equation to look at is 9x squared minus 6x plus 1 is 0. This equation is written down in the form where that ends in is equal to 0, so we can use the quadratic formula right away. Let's check what our a, b, and c are in this case. So our a is the coefficient before x squared, so that's 9. B is -6 and c is 1. So once again, first we calculate the discriminant d, so that's b squared. Note that since b is negative and you square the whole of b, you have to put -6 inside brackets before squaring it. -4 times 9 times 1 is equal to 36 minus 36 is equal to 0. Since our discriminant is equal to 0, then adding it or subtracting it will not matter. In this solution I add it, in this solution I subtract it, but since our discriminant is 0, and therefore the square root of it is also 0, and adding it or subtracting 0 doesn't change anything, we can write down one answer, or one solution. X is equal to -b divided by 2a. And in this case, -b is a +6 and 2a is 18. Now, 6 divided by 18 is 1/3. So you can see that when the discriminant is equal to 0, there's one solution. Let's look at one more equation. Let's look at the equation 2x squared minus 4x plus 5 is equal to 0. Again, the equation ends in is equal to 0, so we can write down our a, b, and c immediately. A is 2, b is -4, and c is 5. And we can see that our discriminant is equal to -4 squared, again mind the brackets, -4 times a times c, or 16 minus 40 is a -24. But hold on, there's something wrong with this, because we have to square, we take the square root of the discriminant, but the discriminant in this case is negative. So I cannot take the square root of it. Well, that's totally true. We cannot take the square root of this discriminant, so we can conclude that since this is lower than 0, we can conclude that there are no solutions. So when the discriminant is lower than 0, there are no solutions. When the discriminant is equal to 0, there is one solution. When the discriminant is simply positive, there are two solutions.